Hello everyone, my name is Pravendra and I am working in AI, ML and Deep Learning. I am faculty at Computer Science Department IIT Roorkee. So can you see my screen?
Yes.
Yes, sir.
Okay. Okay. Yes. End-to-end machine learning project. So here in this session and in next few session, we will discuss how can we develop a machine learning model for the given problem, right? And what are the steps that we will follow to develop a machine learning model for a given problem, right? Okay, so this session, we will walk you through with the complete cycle of a machine learning project. We will see various steps that we will follow uh, in developing machine learning model for a given problem. And since maybe first time you will see these steps, so maybe you may have some doubts, but we will discuss several machine learning problems again and again, and we will follow the same steps again and again. So maybe after discussing few machine learning problems, maybe you will get the better idea, right? Okay, so let's start. Yes. Yeah, so in CloudxLab, you can download uh, you can download. Yes, just 1 second. Yeah, so you can clone this GitHub repository, or directly you can open this GitHub repository, and you can download codes, and you can directly execute these codes using Jupyter Notebook. Yes. So can you see my screen?
Yes.
Yes.
Yes. So this is the link. This link is given in the PDF file. So from these links, and yes, in today's session we will discuss this notebook end-to-end machine learning project, right? So this end-to-end machine learning project is given. Yes. So this is the IPython notebook file that we will be using in executing machine learning codes, right? Okay, so what you can do, you can simply download all files that are given in this GitHub repository, right? So here you can download, right? Download zip, it will download all codes, right? And then what you can do, you can simply go to the My Lab section, right? So here you can go My Lab My Lab section, and then you can start Jupyter Notebook, right? And here you can upload Jupyter IPython notebook file, right? So let's say if you from that folder, if you want to upload let's say end-to-end machine learning project IPython notebook file, so this way you can directly upload to this uh, to this interface, right? Okay. So after uploading, if you click this file, it will open a Jupyter notebook file, right? Yes. So this is one way. Another way is what you can do. You can open a terminal. Let's say if you are using Ubuntu or Linux, so what you can do, you can open a terminal, and then you can clone this repo, right? And then you can write this command cd advanced certification in data science AI get pull or origin master, right? And then you can open this end-to-end machine learning project IPython notebook file, right? So this is another way. Or directly you can download IPython notebook files, and then you can use this upload option to upload that IPython notebook file, right? So any doubt in this?
No, sir.
Okay. And yes, this notebook file, in this notebook file, we will using data sets. So we have to also upload data set file, right? So here, let's say if you want to upload, let's say, yes, let me open it. Yes. So dataset folder is there. In dataset folder, housing folder is there, right? So let's say if you want to create a dataset folder, you can use the new, right? And from new you can create a folder, right? So it will create a folder for you, right? So let's say this way you can create a dataset folder, and in dataset folder there is one more folder, housing, and in a housing folder we have this dataset file, housing dot CSV, right? Yes. So in housing folder we have this housing dot CSV file, right? So it is already available in this GitHub repo, right? Dataset folder, housing folder is there, and then this housing.csv file that we will use in today's session, right? Okay. Yes. So if you want to create a folder, you will use new, right? New, and then this folder option. Similarly, one more folder, you can create extra images, because I will also use extra images in this IPython Jupyter notebook file, right? So you can create extra images folder, and then there are two images in extra images folder, right? So I think yes, this is the folder extra images, and there are two images in this extra images folder, right? Okay. So if you want to execute this IPython Jupyter notebook file, then what you can do, you can create these two folder, dataset folder and extra images folder, right? And then you can just click this IPython notebook file, and this notebook file will be opened. And now you can execute your programs, right? So suppose, let's say if you want to execute, let's say this code, here you will have to just click this run option, and this code will be executed, right? Okay. So now let me quickly discuss this code. So here, since let's say if I want to use Python, then here I will write import sys import system, and then I will write system dot version info greater than equal to 3,5. 3,5 means I want Python version 3.5 or higher, right? So to ensure this condition, I'm writing here system dot version underscore info greater than equal to 3,5. 3,5 means 3.5, right? So here, let's say if you are using this Jupyter notebook file, let's say through Anaconda package. So Anaconda is a package, right? Anaconda is a package manager. So in Anaconda we do have several packages, right? So Python is there, IPython Jupyter notebook software is there, right? So and various libraries are also there, right? And so let's say in Python, in Python also we do have several versions, right? Now, depending our requirement, we will mention here what version we want, right? So suppose if you want Python version 3.5 or higher, then here we can write 3,5, right? Okay. Similarly, this second line, we are importing scikit-learn package, right? So scikit-learn is a popular machine learning library in Python, and here we are writing 0.20 means we want version 0.20 or higher, right? Yes. So this scikit-learn, yes, please
sorry,
ask.
one quick question for the assert keyword, right? If it is false, will it error out, or what will happen here?
No,
It errors out.
let's say you here mention, let's say, very recent version, right? So then you can download that version and then you can use this command, right? So it will throw error that we can easily fix, right? By downloading that
I was
version.
just I was trying to understand what happens if that condition is false. I believe that it will error out. Okay.
Yes.
Thank you.
It will error out, and then that can be possible. Let's say if you have written some unknown version, let's say 5,5, 5.5, right? Let's say 5,5. Yes. So Python greater than 3.5 is required. So here I've written 5,5. So as you can see, we are getting error, right? Because 5.5 does not exist, right?
Got it.
Any other question?
Yes, sir. So we have to first like download that 2.20 version. Then only we have to use that asset command.
Actually, when you download Anaconda package manager, in that package manager, it has several versions of scikit-learn and several versions of Python, right?
Okay.
And in fact, if you use the interface provided by the CloudxLab, here also they have several versions of uh, software, right? So, for example, let's say. Yes. So if you want to use Python to, so are you able to see this this interface that I'm showing here? Python 2, Python 3, 3.1, right?
Yes.
Yes. So let's say suppose if you want to use Python 2, you can just click Python 2 or Python 3. Python 3.10 is also there. TensorFlow is there, right? So lots of options are there. And within Python 2, there are several versions. Within Python 3, there are several versions. So for example, here we are using Python 3.5, right? So we already have these versions, and by just writing this command, we can tell the system that we want version 3.5 or higher, right? Okay. Then here I'm writing import NumPy as NP. So NumPy we use for yes. So this scikit-learn is a very popular Python library that we will use to solve machine learning problems, right? Because in scikit, using this package scikit-learn, we can use machine learning algorithm, right? Directly by just simply writing one line command, right? Okay. So scikit-learn we will use in coming sessions to solve or to implement various machine learning algorithms, right? Okay. Now let's discuss this next library, import NumPy as NumPy. So here NumPy library is used for handling numerical data, right? So let's say, suppose if you want to perform some calculations, some computations using arrays and matrices, then you can use this library. And here I'm writing as NP. As NP is nothing but the you can create, you can think like alias of NumPy or short name, right? Because every time, let's say if you want to use this NumPy library, you have to write the complete name NumPy, right? NUMPY. So to avoid that, if you write here import NumPy as NP, then you don't have to write NUMPY, and only you will write NP in short, right? So if you want to use, let's say, short form, then you will use age, right? Import NumPy as NP, and then you can write NP dot something, right? So let's say here, okay, so in this example, I'm not using NP, but yes, I'm using MPL, right? So here also I'm using this age, right? Import Matplotlib as MPL. So here I'm writing MPL dot something, right? Some function of MPL, right? And I'm not writing the complete name Matplotlib, right? So if you want to avoid writing the complete name, then you can use you can also use the short form, right? Okay. Yes. So this NumPy library we will use for handling numerical data and for doing computations using, let's say, array matrices, right? Okay. Import OS. So this OS provide a way to interact with the operating system, right? So suppose sometimes we want to interact with the operating system for managing directories, for managing files, for managing, let's say, path, right? Or we want service from operating system, then we will use this command import OS, right? If you want to interact with the operating system for managing directory or for managing some files, right? Then we will use import OS, right? Okay. The next library is import matplotlib as MPL. So MPL is nothing but the short form of matplotlib that we have defined. So here you can write anything, right? So here you can also write MP or any short form you can write here, right? Okay, so the library is matplotlib, and matplotlib we generally use to do the visualization, and this library is written in Python. So using this library, we can visualize visualize things, right? Okay, we can create plots, right? Using matplot library. Okay, and this matplotlib pyplot, this is again a sub module of matplotlib, and it provides several functions for creating plots, right? So if you want to plot some figure, if you want to plot some images, then you will use matplotlib, right? Okay. Now here we have several options in this sub package pyplot, right? So this pyplot is nothing but the sub module of matplotlib that we will use to plot, let's say, some figure, some images. We can use this sub module, right? Now in this sub module there are several options, right? So here I am discussing few popular options. So label size. So it will set label size is equal to 14, right? And so let's say if you are plotting in 2D, if you are plotting in 2D, then in 2D we do have two axes, a horizontal axis and vertical axis, right? In 3D we do have three axes, right? So this axis will set the font size for axis label. So let's say for x-axis you want to write horizontal axis, or you want to write something on let's say on x-axis with the font size 14, then you will write label size is equal to 14, right? If you want to write in 20 font size, here you will write is equal to 20, right? So this command you will use to set the font size for axis labels, right? Horizontal axis, vertical axis labels. For example, x-axis, y-axis labels, you will use this command, right? The second option, tick, x tick, y tick, it will set the font size for tick label along the x-axis or y-axis, right? So here the font size is 12, right? So tick means let's say uh, x-axis, let's say, contain some values, and that values you are writing on x-axis. So let's say 5, 10, 15, 20, 25, 30, right? So these values, for these values you will use 12 font size, right? Okay, so let me take one more example. Let's say x tick. Yes. Yes. So x-axis and y-axis, let's say, since here we are writing label size is equal to 14. So if you write here label size 14, so you will use here 14 font size, right? And for tick, you will use 12 font size, right? So here tick means this 2 value, 4 value, 6, 8, 10, 12, 14, and vertical axis 2, 4, 6, 8, 10. These are the tick values, right? Okay. So any doubt up to this point?
No.
Okay. Yes. Now let's say if you want to use service from operating system, because here we have also import OS, right? So using import OS, as I said, we can interact with the operating system for managing directory, for managing files, right? So here we are using OS because we have already imported OS, right? So import OS, so we can use services from operating system. So os.path.join. So this command will join paths, right? So will give you the concatenated path, right? Yes. So yes. So here we are creating one variable, project underscore root underscore directory is equal to uh, dot, right? So dot means the root directory of the project, right? Or you can say the current working directory, right? So this dot refers the current directory, right? Or the root directory of the project is the current working directory, right? This chapter ID is nothing but the another variable. So let's say end-to-end project, right? So as you can see here, yes. So we are
So
we are combining these three values, right? Root directory, then images, and then chapter ID, right? Yes, yes. Any doubt?
yeah, so I just had a quick question and I
Mhm,
missed the first 5 minutes. So the end goal over here, like
mhm.
what is the end goal of this project? Means we have set a goal, or I assume what we are doing right now is kind of a generic thing for all machine learning project that we have to set, right?
Yes, yes, yes. In the next sessions, we will use these libraries. So
Okay,
I'm just discussing what we can do when we use these libraries, right?
okay,
So let's say if you want to train your model, if you want to build some model, then we need to access data, right? Now,
right.
how can we access the data? How can we write some data? How can we save the data? So for which we will use libraries, we will use some commands. So that part I am discussing here.
Okay. But then for this particular problem, is there a problem that we are trying to solve, or a or right now we have not come to that point?
No, no, no. Right now we have not come to that point, and in some next couple of minutes we will start that part.
Okay, okay. Thanks.
Yes. So if you write here os.path.join, it will join these three paths, and you will get the one combined concatenated path, right? So project root directory means the current directory slash images slash chapter ID, and here the chapter ID is end-to-end project, right? Okay. So this is my current directory, and then images. So I have images folder, and then another folder end-to-end project, right? Because the first here the first path is the current directory, right? So this is my the current directory, right? And then the second is the images slash images. So this is the images folder, and then chapter ID. Chapter ID is end-to-end project, right? So this folder. right? So it will give you this path. CloudxLab Jupyter Notebook current path or current location / images / end-to-end project, right? So this command will give you this path, right? Okay. Now you are making here, you are writing os.make make directories image path. Image path means this concatenated path, this path, right? CloudxLab _ Jupyter _ notebook / images / end-to-end project. So this path, comma exist okay is equal to true, right? Which means if you already have this directory, then it will not do anything. And let's say if you don't have this directory, then it will create one such directory, right? So this command os.make dirs will ensure that the directory structure is created if it does not exist, right? Because here we are writing exist _ OK is equal to true, right? So this exist _ OK is equal to true parameters prevent errors if directory already exists, right? If you do not write this this line, then it will throw error if this directory is already exist, right? Okay. Okay, so now let me discuss the function to save figures. So here we have this function save figures, and using this function, we can save Matplotlib figures as the image file, right? Because here we are using Matplotlib library, and we are saving these figures as the image file, right? Okay. So again, we need path, right? We need the complete path where we want to store, we want to save images, right? So this is the path, right? This is the path, right? And as you can see here, this path we are having multiple images, right? Okay. So using this path variable, it will give you this path, this complete path, right? And now you will print here saving figures, figure ID. So let's say figure ID is 1 or 2, or let's say figure ID can be, let's say, attribute _ histogram _ plots, right? So this can be the ID of that figure, right? So here we are printing that we are saving that particular figure, right? And here I'm writing tight _ layout. So this tight _ layout is true. As you can see here, by default, this parameter is true. Tight _ layout is equal to true, right? So when this tight _ layout is true, this will ensure that figure layout is adjusted to prevent overlapping, elements, right? So for example, in a figure, you are plotting sub figure, right? So let's say in one figure you are having let's say multiple sub figure, and if you are not using this option tight _ layout is equal to true, then what problem you may face, that the sub figures may get overlapped, right? So if you want to prevent that overlapping, then you can write here tight _ layout is equal to true, right? Yes. And this parameter file _ extension is nothing but the extension of file. So suppose if you want to store image as the PNG file, then you will write here PNG. If you want to store let's say in JPG format, then you will write here JPG. Or let's say if you want to store in PDF format, you will write here PDF, right? So this parameter you will mention the the format, right? In which format we want to store that image file, right? JPEG format or PNG format, right? And the other parameter is resolution, right? So here, if we are writing resolution is equal to 300, which means we are storing the image with resolution to 300 dpi. Dpi means dots per inch, right? Okay. Yes. So this plt.savefig command will save that particular figure to this location, to this location that path variable contained, right? So path variable contains this location, right? And this plt.save file command will store the figure having figure underscore id. This is the figure id, right? In this format that we have mentioned here, right? So here, let's say if you are mentioning PNG, it will store that figure in PNG format, right? So as you can see here, it is storing all these figures in PNG format, right? Okay. So this is the command to store figures in form of imaging, right? Any doubt up to this point? Okay.
Hey, hi.
Yes.
If this figure ID is the file name or the binary, something like that.
Yeah, it can be anything. So
Okay.
here in this particular case, this figure ID is this name,
Image.
right?
Okay.
Yes, yes.
But this also save the binary as well, right?
Mm-hmm. Because here in this path variable, what we are having images path, right? Images path is nothing but this path, right?
But
And then figure ID
I think
is this name, right?
I think it
And then
doesn't
dot
binary.
and then this extension png, right? Dot and then png, right?
That means they only save the files, not the image files, not save the binary. Binary we don't convert to the images. Then.
No, but here let's say you can, let's say if you're writing here jpg, so it will store in the jpg format. If you want to store in, let's say in so in fact using image pre-processing libraries, you can also convert png format to some other format, right? So for example, in grayscale, if you want to convert, you can also do that. If you want to convert in binary image, you can also do that, right?
Okay. 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 Thank you.
Okay, so now let me discuss the checklist for machine learning project. So for any, let's say for any problem, if you want to create machine learning model, then we will follow these steps, right? So in the first step, what we will do, we will frame the problem and look at the big picture, right? So here in the first step, what we do, we will define our problem, and then we will define the input outputs, right? What are the input and what are the output? And then uh, we will define how can we collect data, and then how can we process the data, right? So these things we have to decide. Then only we can build a machine learning model for any given problem, right? So can you give me any example, any problem for which we can create a machine learning model? Any example?
Prediction of
Handwriting.
stock prices.
Yes, yes. Prediction of prices. Any other example?
Handwriting analysis.
Yes, handwriting analysis, or we can also do. So let's say if you do have, let's say, handwritten digit from 0 to 9, and if you want to predict, let's say, whether that the given image, let's say, is handwritten 0 or handwritten 1 digit or handwritten 2 digit, this is again a classification problem, because you want to classify any given image into 10 categories, right? What are those 10 categories? Handwritten 0 to handwritten digit 9, right? So 0 to 9, there are total 10 categories, and we want to categorize the images into these 10 categories, right? Okay. Now, suppose if you want to solve this problem, in the first step, what exactly we will do? How can we solve this problem? If we want to solve this problem, we need data, right? We need
Yes.
handwritten data, then only we can solve this problem, right?
Right.
And then we have to also identify the problems, right? Since we are solving a handwritten digit problem, so as you know already, if people write 0 digit or let's say digit 1, there can be lots of variation in writing, right? If you're typing that digit, then yes, there won't be any much variation, depending on what font you are using and what um, yes, so it will be uniform, right? But when you use the handwritten digit, right? So in handwritten, people write let's say digit 2 in different shapes, right? So there we will face several problems, right? So in this first step, we will identify our problem, and we will identify the input and output. So here, what are the inputs? Images. Images are the inputs, right? And what is the output? Output is 1 out of 10 category, right? Because there can be total 10 categories. Handwritten digit 0 to handwritten digit 9, right? So there can be total 10 categories. So output will be 1 of 10 categories, right? So output can be handwritten digit 0, output can be handwritten digit 5, right? Or handwritten digit 6. It can be any category from 0 to 9, right? So this is our output, and what are our inputs? Images are our input, right? Okay, so in first step, we will identify images and inputs and output, right? The second step is the get the data, right? So in second step, we will collect data to train our model, to build our model, right? Because in machine learning models are data driven. Machine learning models are data driven. So we need data to train any machine learning models, right? Okay. So in data, we will collect the data using which we can create a machine learning model, right? And data can be structured data, can be unstructured data. So let's say when you are collecting data in some in rows and column, right? In a tabular data, if you are collecting, right, tables with numerical values, or let's say table with some categorical features, then it is called the structured data, right? Because we do have structure present in our data, right? So for example, in tabular form, if we are arranging, then we have rows and columns, right? Okay. The data can also be unstructured data. So for example, images, right? If you are collecting images, then now you are collecting unstructured data, images, text, audio, video, right? All are the example of unstructured data, right? Yes. This third step, explore the data to gain insights, right? In third step, what we will do, we will understand our data, right? We will do, and here you can do several types of analysis. So for example, what you can do, you can visualize your data, right? Using Matplotlib. I just discussed Matplotlib, right? So using Matplotlib, you can use the Matplotlib library to plot histograms to visualize your data, or heat map you can create to visualize your data, right? So in third step, you can visualize your data to gain more insights, or let's say uh, we have some missing data, right? Missing data can also be possible because we are collecting data. So maybe uh, some outlier, some noise may also be present in the data, right? Because we are collecting these data through some sensors, right? And sensors are not ideal, right? So sometimes we may get faulty data, right? Due to fluctuation in, let's say, in voltage, or in some yes, and there can be several other reasons also, right? So data can be noisy, data can have missing values, right? So sometimes we also need to pre-process our data to clean our data, right? Now, to do cleaning of data, or let's say to impute the missing data, we need to first understand our data, right? So this is why in the third step, we are exploring the collected data to gain more insight, so that we can do pre-processing if required, right? Okay. The fourth step, prepare the data for machine learning algorithm. So here in the fourth step, we will do the pre-processing steps, right? So for example, what we can do here, we can do data cleaning. Suppose in the collected data, we are having some missing values, then we can impute those missing values. So if, let's say, if some outliers are there, then we can use some outlier detection or outlier removal techniques to clean our data, right? And sometimes we also use normalization. So we do normalize our data, right? So normalization again comes under pre-processing techniques, right? So, and in fact, there can be several pre-processing techniques that we will see in the next sessions, next coming sessions, right? Okay. So here in fourth step, we will do some pre-processing. We will pre-process our data. The pre-processing can be data cleaning. The pre-processing can be, let's say, outlier detection, can be missing some values, right? Can be some normalization. It can be some sort of selection, right? It can be even the splitting. So suppose if you want to split your data into multiple parts, then in step 4 you will do that, right? Yes. Next step, explore many different models and shortlist the best one. So here in step 5, what we will do, we will try several machine learning models to do their task, right? Now the task can be anything. So suppose, let's say that the task can be the classification task. Now in machine learning, we have several models, several algorithms to do the same job, right? Here the problem is we don't know which model will work better than the other model for our problem, right? So then what we will do, we will try several machine learning models, and then we will pick the model that maximizes our accuracy, that maximizes our performance, right? Now, so to do that, we have to explore several models first. Then only we can select the best possible model, right? So in step 5, we will try several machine learning models, and then we will pick the model that maximizes our accuracy, right? In the step 6, we will fine tune our model. We will tweak our model to optimize our model to get the best performance, right? So in the 6th step, what generally we do hyperparameter tuning. Hyperparameter is parameters of that machine learning model that we can tune to optimize the performance of machine learning model, right? Yes. So here in 6 step, you can think we will do some tweak in machine learning model to optimize its performance. Now that tweaking can be hyperparameter tuning, that tweaking can be regularization, it can be even some steps that we can do to generalize its performance, right? Yes. So in fine tuning, we will tweak our model to optimize its performance, right? And the seventh step, present this solution. Here we will present our developed model to to end users, to some stakeholders, right? So suppose, let's say you are developing a machine learning model to do some task, right? So then after developing that model, what you can do, you can present that model uh, um, to some companies and let's say to some end users, right? Because you are developing, you are building something for the society, right? So then you will present that solution, right? Okay, the next step is launch, monitor, and maintain the system. So after presenting the solution to the end user, you will launch that solution, you will deploy the developed machine learning model, you will monitor its performance, right? And you will do regular updates if required to maintain the developed machine learning model, right? Okay. So any doubt in these steps, step 1 to step 8?
Excuse me, sir.
Yes, yes.
Sir, can you please explain that fine-tune model again?
Okay, so actually here I am discussing these steps very briefly. So maybe you may have several doubts at this moment, but since we will use these steps throughout solving several machine learning problems. So we will repeat these steps again and again. So maybe after 1 or 2 iterations, you will get the clear idea. So and yes, so here in step 6, you can in broad sense you can think we are tweaking machine learning model to get the optimized performance, right? So by tweaking, what I mean, here we have 2 types of parameters. One is the model parameters, the parameters that we are training to build that machine learning model. The other types of parameters are called the hyperparameter. So hyperparameter are not same as the model parameters. Hyperparameters are the parameters that we can tweak to optimize model performance, right? Okay, so in next sessions, I will discuss machine learning models. Then there I will show you some hyperparameters, and I will show how can we tweak these hyperparameters to get the optimal performance, right? Yes. So in step 5, we are learning model parameters. We are learning optimal model parameters to get the optimal performance. And in the step 6, we are tweaking hyperparameters. We are not learning model parameters, and we are learning the hyperparameters, right? The model performance depends on model parameters plus the hyperparameters, right? So model performance depends on both model parameters and the hyperparameter. So in step 6, we are we are tweaking hyperparameters, right? Any other doubt? Okay. Okay, so let's take a 10-minute break, and then I will start building a machine learning model to predict housing prices in California using California census data, right?
Okay, thanks.
Okay. So now let's start building a machine learning model to predict housing price using some data, right? So, and here, what data we are using? We are using California census data, right? Okay, so first let me ask one simple question. Let's say if you want to predict house price, what parameters, what variables we need?
The location.
Yes, location, because
Mr.
how, yes, because house price depends on location, right? Any other variable?
Per
The
square rate,
size, yeah,
Yes,
size,
size.
the
per
size
square
of
rate,
the size and type of the house.
Yes, type of house also. Yes. Any other variable?
square rate, per square rate,
Yes, yes. And any other?
Means we need the historical prices, right? Like of past few years, correct?
Yes, yes. So we need several features, or what we can say, we need several parameters to predict the housing price, right? And also the construction level, right? So for example, if the house is a multi-story building, or let's say if only a single story building, the price also depends on the type of construction, right? And the location, right? So there are several parameters uh, that change house price, right? And if we somehow know the relationship between the house price and these variables, then using that relationship, we can predict house prices given these variables values, right? So for example, given the location, locality, given these variable values, we can predict any house price, right? So here our goal is to predict price of house given some values, right? And house price depends on these parameter values, right? Okay. So first step we have already completed, right? We have framed the problem and we have looked at the big picture, because now we know what are our inputs and what are our output. So here in this particular problem, the output is the house price, and input you have already mentioned, right? So these are our inputs and the house price is out. Okay. Now house price is a real number, or is a integer number? House price is a real number, right? Because
Real number,
real,
real
yes,
number.
because it can be anything. It can be, let's say, 11.56 K dollar, right? It can be anything, any real number. It can have any real value, right? So here in this case, house price is a real value, right? Okay. Yes. Now we are visualizing our data. We are visualizing our data to get more insights, right? But here the problem is we can only visualize data in 2D or 3D, right? We cannot visualize data beyond 3D, right? So up to 1D we can visualize, 2D we can visualize, 3D we can visualize, but beyond 3D we cannot visualize, right? Okay, so here we are visualizing our data in 2D, right? So for this 2D visualization, we are using two parameters, two features we are using, longitude feature and latitude features, right? But there can be several other parameters also to do to solve this housing price prediction problem, right? But we are here only plotting these two parameters because we can only visualize in 2D or 3D, right? Okay. So here we are plotting um, our data using two variables or using two features or two parameters. One parameter is the longitude, another parameter is the latitude, right? Okay. And here we are we are we are plotting we are plotting circle to show the populations, right? So here if circle is small, which means less population. If circle size is, let's say, big, which means high population, right? So the circle size of circle here represent the population, right? And price color represent the price, right? So blue means less price and the red means high price, right? So in this visualization, yes, in this visualization, the circle represents the population and the size of circle represent the population type, right? So let's say if the circle size is small, which means less population. If circle size is let's say high, which means more populations, right? Similarly, the color represents the price value, right? So blue means price is less, red means price is high, right? Okay.
So if so if there is a big circle of red color, then that means
yes, big
population...
circle or yeah, red color means for that particular region, for that particular, because here we are plotting using latitude and longitude, right? So for particular latitude, for particular longitude, you can get to that position, right? Now for that particular position, we are having more populations and house we are having costly houses, right?
Okay.
Cost is very high. Yes. So here in this step, we are visualizing our data to get more insights of our data, right? Yes. Okay. So you can use this Panda libraries to visualize your data. Okay. So let me go to the IPython Jupyter notebook file. Okay. Yes. So here I'm first calculating the path where I have this file, right? So as you can see here, the path is the current library, current directory slash dataset slash housing, and the file name is housing.csv. So this is the path and housing.csv is the file name, right? Okay. Yes. So here we are first computing this path, right? CloudxLab _ Jupyter _ notebook / dataset / housing, right? Okay. Now we are importing pandas as PD, right? So pandas is a library that we will use to handle tabular data structure in Python, right? So suppose you are having some tabular data, right? So as you can see here, what type of data we are having? We are having in our data set, we are having some rows and some columns, right? So we are having tabular data, right? Because some rows are there, some columns are there. So if you want to handle the tabular data, then you will use pandas library, right? Okay. So which is a common data structure for handling tabular data in Python, right? So yes. So the CSV path in this variable CSV path, we will have the path, right? The path of our file, CSV file. And then we will use this command read CSV to read housing.csv file, so, right? If you want to read this CSV file, you can read using this command read underscore CSV. If you want to write something, then you will use write underscore CSV, right? Okay. So since here we want to read, so therefore we will use read underscore CSV and then the path of that file. And here what is the path? Path is CloudxLab underscore Jupyter underscore notebook slash dataset slash housing dot CSV. So this is the path of this file, right? So here we are passing file path and we are reading housing dot CSV file, right? Okay. And here why we are using Panda libraries? Because we want to do some manipulation, we want to do some analysis over tabular data, right? So therefore we are using here Panda library. Okay. Then this command housing.head will display the some top rows of the data, right? And in fact here by default it will display first 5 rows of the tabular data, right? As you can see here, if you write housing.head, this function will return first 5 rows of data set of our data set, right? Yes. Any doubt in this code?
So if we want to present the whole data of the table, then what is the command rather than
Then
housing dot?
yes, so here you will mention top is equal to 100, it will print 100 rows, right?
Okay, so we have to be passed the number.
Yes, yes.
So this CSV file of this housing data means we have got it from somewhere.
Yes, yes. So in fact, you can also open this CSV file, right? So let me open this file. Yes. So as you can see in CSV file, there are how many tuples are there? How many rows are there? Yes. So this data set contains 20,641 rows, right?
I know, but from where did we source this data? I mean, this is a real data.
Yes, so real data collected by yes. So this data set we have not collected. This data set we are using. Yes. So let me give you the source. Yes. So this data set is California census data set, right? 1999. Sorry, 1990.
90.
Yes.
Okay.
Okay. Yes. So after visualizing this data, you can here see the parameters that we can use to predict the house price, right? So for example, latitude, longitude, we can use these features, we can use these parameters to locate house, right? Latitude, longitude we can use to locate that house. Then total number of rooms, total bedrooms, population, household, median income, median house value. So these are the value the data set contains, right? And
so
here,
sorry, so this housing.head thing, I mean, this is just to visualize. I mean, this is not doing anything programmatically, right? I mean, this is just for us to see
yes,
or
yes,
print the load the housing.csv and print the first couple of rows. That's it, right? It
yes.
is not doing anything else, any processing.
No, it is not doing anything else. And you can think in broad sense that we are having these many parameters, these many features, right? And here what we want to predict this parameter value, median house values. This value we want to be predicted given the other parameters values, right? So in our data sets, we have yes, so we have house value, right? Now let's say for given latitude, longitude, for given, let's say, age, total room, right? We want to predict the house value. So we want to develop one machine learning model. We want to develop some mathematical mapping so that given these parameters, we can predict the house price, right? Okay. Yes. So this data set contains several attributes: population, income, median house price, and several more, right? Now here our goal is to predict house price. Our goal is to predict this parameter value given other remaining parameters, right? So if we are given some longitude value, some latitude value, we are given some age, median age, we are given some total value for some total room value, total bedroom value, population value, household value, right? Medium income value, right? This ocean proximity value. Given these values, can we predict house value? This is our goal, right? Yes. Okay. So here we are dividing, we are using here block groups. So block groups are nothing but the smallest geographical unit for which the US Census publish sample data, right? So here you can think this circle is a block data, right? So one circle means one block data, right? Yes. So circle means block group, right? And a block group typically has a population of 600 to 3000 people, right? And block group is nothing but the districts, right? So one circle means one district, right? In this data set. And one circle or one district or one block group can have 600 to 3000 people, right? Okay. Now here our goal is to predict the housing price given other parameters values, right? So our model should learn from this data, and then after learning this machine learning model, we will be able to predict median housing price in any given district, right? So given any circle, we can predict its price using machine learning model, right? So for that, we will use this data, right? We will use this data to train our model, to build our model, and then we will use that model to predict housing price given any district, given any circle. We will predict the housing price, right? Okay, so any doubt in this example?
No.
Yeah. Okay, so now we will frame our problem, and we will solve few questions. So what exactly is the business objective? So here, if you want to predict the housing price, then we can use housing price for investment purposes, right? How does the company expect to use any benefit from this model? Yes, so company can use this model to predict the housing price that the company can use in several other decisions, right? So for example, I give you one example. Let's say investment. So company can decide investment policy using housing prices, right? Now here again we have to solve several problems. So for example, which algorithm we can select, because we have several machine learning models to do the same task, right? So which model is performing better? So again we have to try several models, then we will pick the best model, right? What performance measures we will use to evaluate our model, right? How we are evaluating our model, right? So there can be several performance measures. So we have to pick one performance measure to measure the performance of our model, right? And then hyperparameter tuning, right? If it requires to tweak our model, right? So we need, sometimes we do hyperparameter tuning also to tune our model to get the best performance, to get the optimal performance, right? Okay. Yes. So here in house price prediction, we will use data, right? We will use district data or circle data. We will use, right? Because in this figure, the circle means the district, right? So we are given data and we are using the data to build a machine learning model. Now using that machine learning model, we can predict a house price, right? So we are using some data, we are building a machine learning model, and now using that machine learning model for any given district, we can predict house price, right? Now that house price we can use to solve some other problem. So for example, here we are solving a investment analysis problem, right? We want to maximize our return, right? Now to maximize our return, we have to solve this problem, investment analysis problem. Now in this investment analysis problem, we are taking housing price as a input, right? So we can predict housing price. We can use that housing price to solve some other problem, right? Yes. So as you can see here in this figure, given some data, we are training our model, and using that model we can predict house price. That house price we can use as another input to solve some different problem, right? Yes. So model's output, which means the prediction of machine learning model. So here what is the prediction of machine learning model? Housing price, right? So model outputs will be fed to another machine learning system, right? And then system will determine whether it is worth investing in a given area or node, right? So as you can see here, we are solving two problems. First problem is house prediction, house price prediction, and the second problem is this investment analysis, right? Okay. Okay. So now we will frame the problem and its solution, right? So what the current solution look like? It often gives the reference performance as well as insight on how to solve the problem, right? So we will use some performance metrics to show the performance of our machine learning model, right? Or what we can do, we can use manual method also, right? So for example, the same problem, the same housing prediction problem, you can take help from experts that can use some manual methods to estimate housing price, right? So one method is to use some machine learning model to use some automatic method, and that automatic method will predict housing price given these parameters values, right? So one path is to use some automatic model. Automatic model means machine learning models you can use to predict housing price given these parameters values, right? The other option is you can take help from experts, and expert can manually estimate the housing price using using up-to-date information about that circle, about the district, right? Expert can use complex rule to come up with some estimation, right? And if you are doing this manually, then this is very costly and time consuming, right? And typical error rate here is 15%. So here 15% is the error in estimating house price, right? But if you automate this process, error rate is very less as compared to the manual method, right? Okay. So there are several benefits to use machine learning models, right? Because by using machine learning models, you can automate this process. You can, and yes, if since you are automating this process, so therefore it will save lots of time, right? And again, machine learning, if you are building a machine learning model, you will get a very cost effective solution, right? And in terms of performance, again, you will get much better performance when you use the machine learning model, right? Any doubt up to this slide?
No.
Okay. Yes. Now, in the next step, we will frame the problem. So here, if you want to frame the problem, then we need to first decide several steps. So, for example, we need to first decide whether we are doing supervised learning, or we are doing unsupervised learning, or we are doing reinforcement learning, right? So what type of learning we are doing, we have to decide it first, right? The second decision we have to take, are we solving classification task or regression task, or we doing something else, right? And the third decision we have to take, the should we proceed with the batch learning or online learning? Okay, so let me discuss these terms one by one. Okay, so here the batch learning means we are we are building our model using complete data, right? So let's say if you are building machine learning model using the complete data, then you are doing batch learning. right? Batch learning means you are learning machine learning models using complete data. So here batch means the data, complete data. In online learning techniques, sometimes at a time we only have a part of data available with us, right? So since only one part of data is available and we do not have access to the complete data, then we can use online learning techniques to build machine learning models in such scenarios, right? So for this house prediction problem, hello. Okay. So let's say here in this house price prediction problem, since we have the complete data, so here we can use batch learning, right? Because we have the complete data, right? But let's say if we do not have the complete data, then we will use online learning techniques, right? Okay.
So how do we decide whether, how do we know we have the complete data or not? I didn't understand.
No. So let's say you want to predict the housing price using, let's say, 1990 California census data set.
Right.
Then in this case we have complete access to this data set, right? So since this data set we are using a standard data set, right? So
Okay.
we can use the batch learning techniques, right?
Okay.
But let's say you are
you provide
solving. Yes.
when online learning techniques will be used?
Yes. So in fact, later we will see examples where we will use online learning techniques. So in online learning, you can think we do not have the complete data set. So for example, let's say you want to recommend. So let's say you are developing some product, let's say for Amazon, right? Now on Amazon, let's say for any given customer, you want to recommend something, right? Now initially we know very little about that customer, right? So one option is either we can get the complete information about that particular customer, then only we can recommend, right? The other option is, even if we have a very less information about that customer, we can give him or her some recommendation, and then we can correct our model incrementally, right? So this is the case where the online learning techniques we can use, because now we do not have to wait for the complete data, and we can even use machine learning techniques even if we have a part of data available with us, right?
So online learning, I'm sorry, maybe I missed it. That is, so batch learning is clear. Online learning means there are some other techniques which are available online, or?
Yeah, so online learning, so you can think learning techniques can be categorized in two types: batch learning and online learning, right? In batch learning, we will use, uh, yes, so batch learning techniques assumes that we have access to the complete data set.
Data, correct.
Online learning techniques assumes that the part of data is available with us, right?
Okay.
Yes. Yes, and online learning also known as incremental learning, right? Because in online learning techniques, we train machine learning models incrementally, right? And I gave you one example, recommender system, right? So initially, we do not have enough information for the user, but after few times, we can collect relevant data by analyzing users' activities, and then we can recommend, right? So in this case, we will use online learning techniques, right? Because we will not wait for data collection, and in fact we can start giving recommendations, right? Or let's say online advertising. There are lots of websites, so Google ads, Facebook ads, right? So depending upon user behavior, they will display ads, right?
Right. But that will be true, Professor Praveen, true for many things, right? Like where we keep on updating or learn incrementally about the user behavior.
Yes. Because here the problem is we do not have access to the complete data set, and we only have access to the part of data set. So therefore, what we can do, we will train our model using the available data sets, and at later point when we have some more data, we can fine tune our model, we can improve our model using the available data sets that we have at that time, right?
When you say data set, you're talking about the training data set, right?
Yes,
Just
training data
before
set.
creating the model.
Yes.
Okay.
Yes.
So basically, for example, if we have a classification problem and we have 500,000 records available, that would be batch learning, right? Because we'll create a model and then use it for new data.
No.
Is my understanding right?
Yes. So actually, the learning techniques you can divide in two types: batch learning and online. Online learning techniques will incrementally update machine learning models. In batch learning techniques, for a given data set, it will train your models, and then you will use that model for future time prediction, right? So batch learning techniques will not update your model, right?
Okay, got it.
And incremental learning techniques will update your model incrementally. Whenever you are having some more new data, it will update your model incrementally, right?
So when we say we do not have enough data available, so do we mean we do not have enough?
No. So it's just a notation. In fact, what you can do manually, you can use batch learning techniques and you can do the online learning. So let's say after 1 month, you are having some more data. Then what you can do? You can use batch learning techniques to fine tune your model, right? So it's up to you, right? Because generally we update our model, right? Because let's say yes.
That when we say we do not have, then do we not have enough rows, or some columns may also not be there, some features may also not be available?
Yes, so rows.
But all the features that you want to train on should be available.
Yeah, so then there are some machine learning techniques using which we can handle that also, right?
Okay.
So for example, let's say if you are building a deep learning model, right? If you change the number of feature, the input layer size will change, right? Then what you can do, you can simply change the input layer and you can use the same model. But then you have to do fine tuning. You have to fine tune your model, then only you can use, right? And let's say yes, so I will give you examples in later session, right? So it is possible to increment, to add new rows, and also at the same time new columns, right? But then we have to do something extra. If you are adding columns, if you are adding some more features, then we have to do something extra, right? But if you are only adding the rows, then the same model you will fine tune. You will not do any changes in that model. But if you are adding some features, then some changes may required in some algorithm. I'm not saying in all algorithm, right? In some, so for example, let's say if you are using probabilistic model, so there you can add columns very easily, right? But if you are building a deep learning model, so then you have to do changes in the model, then only it can support new features, right? So depending on what algorithm we are using, we can also add columns, right? With some modification in model architecture. Okay, so here since we have complete data, so therefore we will use batch learning, right? Okay, so now let me discuss supervised, unsupervised, and reinforcement learning. So here the supervised means we are having label data, right? So let me give you one example here. So I think machine learning part already covered, right? What is machine learning? What is artificial intelligence, right?
Yes, yes.
And yes, I'm also sharing these slides in the chat section. So please download this file. Okay, so let me also share the IPython Jupyter notebook file, right? Okay, so I've shared. Please download PPTs and IPython Jupyter notebook file. Okay, so let me briefly cover these slides, because I think this topic has already been covered, right? So in machine learning, we are developing algorithm, we are developing a model to solve some problems, right? And machine learning is a branch of AI, branch of artificial intelligence. And here in machine learning, what we are doing, we are detecting patterns, we are detecting structures present in the data to solve that problem, right? And we will use that model to make predictions using the future data, right? So for example, let's say if you want to classify spam versus non-spam emails, right? If you want to classify, let's say for any given email, you want to classify that email as spam email or versus non-spam email, then you can do this classification using machine learning model, right? And in machine learning models, it will detect patterns, structures, trends present in the data, training data, and using these structures, patterns, or trends, we can make predictions about the future data, right? Because why we are building machine learning models? We are building these machine learning models to make predictions for future data, right? Because we are building these models to predict on over future data, right? So we will train a machine learning models, and we will use that model in future. For future data we will use, right? So it will predict, it will give predictions using some future data, right? And
what do we mean by structures and themes here?
Sorry, can you repeat?
What do we mean by structures and themes? Patterns and trends is clear.
No, right. So number of airline passengers depends on the month, right? So for this type of data, we will, you can call it as pattern or trend. What trend this data is following, right? To do the prediction for the future month, right? Okay. So these machine learning models are heavily data driven, right? As you can see, we are building machine learning models using data. So these models are called the data driven model. And we also have another types of algorithm. That algorithm are called model. What we will do? We will learn this distribution, right? Probabilistic distribution. So given this image, what is the probability that this image belongs to cat class? Given the image, what is the probability that image belongs to the dog class, right? So this is the distribution for dog class. This is the distribution for cat class. So probabilistic classifier will follow this approach, and it will learn the distribution, right? Conditional distribution it will learn. So what is this blue distribution? It will give you the dog probability for any given image. Given any image, what is the probability that that image belongs to the dog class, right? And this red distribution will give you the probability for cat class, right? Yes. Yes. And I think applications you already know, right? Machine learning applications. So there can be several applications for machine learning. For example, what you can do, you can use machine learning models to describe this image, to generate this type of caption. You can use machine learning models, right? In spam versus non-spam classification, you can use machine learning models. In recommendation system, you can use machine learning models. Healthcare system, we can use machine learning models. Autonomous driving, we can use machine learning models, right? And online fraud detection, we can use machine learning models, and several more applications are there, right? Yeah. Okay, so machine learning is like an exam, right? Because here in machine learning models, we are building this model for future data, right? We are, for some given data sets, we will build a machine learning models, and we will use that machine learning models for future data, right? So here there are two types of accuracy: the training accuracy and the test accuracy. So test accuracy means the future data. Training accuracy means the accuracy that we are getting over the data that we are using to train our model, right? So here the test accuracy matters and not the training accuracy, right? Just like so you can there exists an analogy between the exam and the machine learning models, right? So in exam also, what questions you are practicing before the exam, right? So it does not matter, right? What matters in the exam is what how you are solving your question in exams, right? How you are attempting your questions in exam, and not the practice that you did in the past, right? In the same way, how your model is performing on over the training data, we do not care, and we only care about how your model will perform over future data, because here our goal is to build machine learning model for future data, right? Why we are building these models? Because we want to predict something. We want to predict something for future data, right? So this is why we are building these models. So that's why the test performance do matters and not the training performance, right? Okay. Now, machine learning models can be categorized in three parts: supervised learning, unsupervised learning, and the reinforcement learning, right? So, supervised learning means we are using label data. Label data means we are having data and its output label, right? So, for example, yes, this example. So here, what is our input? Image. Image is our input. So, for example, this image is the input, right? And what is the output label for this image? Dog. So, since here we are given input comma output, or we are given label data. Label data means label we already know, right? This is the dog image, this is again the dog image, this is the cat image, right? So we already know the label of this image. So this type of data is called the labeled training data set. And if we are building a machine learning model over labeled data, then that type of machine learning is called the supervised learning, right? So in supervised learning, we use labeled data. Labeled data means input we know and the output we also know, right? So here, what in this particular problem, dog versus cat classification problem, dog versus cat classification problem, input is the image and the output is either dog or cat, right? Okay. So in training data, for the training data, since we already know its label, so therefore it is called the label data, right? In unlabeled data, we are only given the inputs and we don't know the associated labels, right? So only these images are given and we don't know whether this image belongs to the dog or cat class, right? If we are learning a machine learning model using such data sets, that learning is called the unsupervised learning. Unsupervised means we do not have supervision because we are only given the unlabeled data, right? Label we do not know, right? Which means we are learning here uh, unsupervised way, right? And when we have the label data, which means we are learning in a supervised manner, right? Because supervision is available, right? Here, what is the supervision for this input image? Dog. Dog is the supervision. Here, for this particular input image, cat is the supervision. So this is why this technique is called the supervised learning, because supervision is available, right? Here we do not have the supervision, so that's why this learning is called the unsupervised learning, right?
No, but then in unsupervised learning, in case of unlabeled data, I mean, how will we? I mean, someone has to mention, right? Like this image is of a dog, or this is of a cat.
Yes, yes. So actually, I'm not saying you can solve all problems using supervised techniques and unsupervised, right? Some techniques, for some techniques, we need supervision, and some techniques, for some tasks, we, even if the supervision is not given, even then we can solve that task, right? It depends on what type of task we are performing. So for example, let's say if you want to group images into same type. So for example, you want to group these images in such a way all dog images fall in one group and all cat images belongs to the another group, right? If you want to do this type of task, classification, grouping task, and this task is called the clustering. You are clustering your data set into different cluster, different groups, right? In one group you are having all dog images, in other group you are having all cat images, right? If you want to do such type of clustering, such type of grouping, then we do not need the label data. Even if the label is missing, we can use machine learning model to do this task, right? So clustering. So this is why this clustering or grouping is a unsupervised learning techniques, because here we will not use the supervision, right? But let's say if you want to do the classification, you want to classify that this image belongs to dog class, this image belongs to the cat class, then we do need supervision, right? So that's why image classification regression comes under supervised learning workflow, right? Because if you want to solve classification problem, if you want to solve, so classification means for any given input, you are predicting some category, right? So for example, here this task is a classification task, right? Because here you are classifying your input to either dog category or cat category. So this problem is a classification problem, right? The other problem can be the regression problem. In
But
regression
how they are different, the classification and cluster, how they are different?
No, so here is in another group you are having all dog images, but since we do not have the supervision, so we do not know this is the dog cluster, which cluster is the cat cluster, we do not know, because we don't have the labels, right? We are only given the unlabeled data. And for the sake of simplicity, I'm taking here this simple toy example. You can think we are having several classes, right? So for example, let's say you are having 1,000 classes, 1,000 categories, and we do not know the labels. So if you apply clustering or grouping, it will create 100 clusters, right? Are you getting my point?
Yes, yes, yeah.
Okay, and this reinforcement again a learning technique where we can use some reward function to learn machine learning model. So for example, Mario game, right? In Mario game, when agent moves, you can get some reward, right? Okay, so mainly I will cover supervised and unsupervised techniques, right? And I will not cover the reinforcement learning part, but yes, reinforcement learning you can use to train an agent using some reward function. So agent will interact with the environment, and depending on agent action, the environment will reward. Environment may give positive reward or negative reward, and accordingly the model will be optimized, right? Okay, so supervised learning, here the example are the classification and the regression. So classification I have already covered, right? So for example, let's say if you want to do this type of task, this type of classification task, you want to categorize this image into dog or cat or some other category, then this problem is the classification problem, right? And to solve the classification problem, we need label data. We will use the supervised learning workflow, right? In regression, we will predict a real valued output. For some given input, we can predict a real valued output. Okay, so now can you give me one example of regression task? Example of regression task.
Predicting the temperature?
Yes, house prediction, the same problem is the regression problem, right? Because in house price prediction, what we are doing, we are predicting a real valued output. Given some values, we are predicting a real valued, right? So here, what we are predicting, real valued output, right? So this problem is called the regression problem, right? Yes. Yes, and you are correct. The temperature prediction is again a regression task, because the temperature is a real valued number, right? Real valued output you are getting. Okay. So if you solve classification task or regression task, then we need label data, and we will use the supervised learning workflow, right? There exists some task where we do not need the label data, and even if we are given only the unlabeled data, we can solve that task. And here the example is the clustering or the dimensionality reduction. So in dimensionality reduction means we are reducing data dimensionality. So suppose initially we are having a three-dimensional data and we want to reduce from 3D to 1D or 3D to 2D. To solve this problem, we can use unlabeled data and we can use the unsupervised learning workflow to solve this problem, right? In clustering, I already gave this example, right? For the grouping problem or the clustering problem, we will use unsupervised learning workflow where we are only given the unlabeled data and we can solve this problem, right? Okay, now let me briefly discuss the supervised learning workflow. What exactly we will do in supervised learning. Okay, so here I am taking a binary classification example. Binary classification means we are only having two categories, right? Binary means two cases, right? Positive or negative, 0, 1, right? So this cat versus dog classification is an example of binary classification problem, because here for any given image, we are classifying that given image into two classes, either dog or cat. So it's a binary classification task, right? Because we are classifying, and how many classes we are having? Only two classes. So that's for binary classification, right? Okay. And since we are having the labeled data, so therefore we are doing supervised learning, right? Supervised learning means we are learning machine learning model using labeled data. Okay. Now here the problem is since we are having images, the machine learning model cannot directly understand images, right? Machine learning model can only understand vector, can only understand the representation, right? Numeric representation. So in first step, what we will do, we will convert this image into some numerical representation that machine learning model can understand, right? So, and this step is called the feature extraction. So in feature extraction, what we do, we extract feature for any given input. Now that input can be a record, can be a image, can be a audio file, can be a video file, depending upon what type of data and what type of problem we are solving, right? So since here we are dealing with the images, so therefore raw data we are having in the form of images. So we will extract features from these images, and then these features are nothing but the numerical representation. These features are nothing but the vector that machine learning model can understand, right? Okay. Then we will learn a machine learning model using these numerical representation, numerical vectors, and then we will train machine learning models using these data, right? So in data, we are having several dog images, several cat images, and we will train our machine learning model using this data. And assume this is your machine learning model. This linear model is linear separator is your machine learning model, right? Okay. Now, as you can see here, all dog images lies one side of this linear boundary, and all cat images lies in another side of this linear boundary, right? So this boundary is in this case is a machine learning model, right? Okay. So let's say using some techniques you have learned this machine learning models. Now my question is what you will do at the test time. So let's say for any given text image, what steps you will do, because we are building these models for future data, right? So using this data, we will train our machine learning models. Now, how can I use the same machine learning model for the future data? So suppose at the test time, I am given this image and I want to predict whether this image is a cat image or a dog image. Now, what steps I will follow? I will give this image as an input to this machine learning model, right? So can I give this image directly, or I have to convert this image into some numerical representation first?
numeric.
Yes, because model cannot understand images directly. We have to first convert images, raw images, into numerical representation. Then only machine learning model can understand. So in the first step, we will extract a vector, or we will extract some numerical representation, and we will pass this numerical representation to our model as an input. And now let's say if depending upon let's say if this particular vector lies on this side, which means the cat image, and let's say if that particular vector lies on this side, other side, then this image is a dog image, right? Okay. Yes. Unsupervised learning, in unsupervised learning workflow, we are only having unlabeled data and we don't know the associated labels. But again, since we are building a machine learning model, so directly we cannot pass images into our model. So we will extract, we will convert these images into some numerical representation, and then we will use machine learning models. And here we will use unsupervised learning techniques, right? Here we are using supervised learning techniques because supervision is available with us, right? In this case, we do not have the supervision, so therefore we will use unsupervised learning techniques to learn this machine learning model. And let's say if you are solving a clustering problem, if you are solving a grouping problem, it will create groups depending on the similarity present in the data, right? So for example, let's say if you are having data of two types, it will give you the two groups, right? In one group, we are having images belonging to images having the similar property, right? So as you can see, in this group, we are having all cat images. In this group, we are having all dog images, right? Because all these cat images share some common attributes, share some common property. That's why this model is grouping all these images into one single group, right? And all these dog images share some common property. So that's why these images we are grouping in, machine learning model is grouping in another group, right? Okay.
But how we are so we have to train the model for the properties also to match this property, matching to cat and this property matching to dog.
Yes, so model will do depending upon what type of algorithm we are using. So if you want to do cluster, if you want to do grouping, there exist several machine learning algorithms, and depending upon what type of algorithm you are using, it will use some procedure, right? And that procedure internally use similarity measures, right? It will use internally, it will measure similarity if two images, in broad sense, I'm saying in broad sense, not in the finer level. So if two images or two inputs look similar, then model will group those inputs into the same group, right? In a broad sense. Now, the exact working depends on what type of algorithm you are using, right? Okay. Now, yes. Okay. So now let's discuss these models from geometric perspectives, right? So in geometric perspectives, data points you can represent it as a points or vector in some vector space, right? So for example, the 3D data you can represent in as a point in 3D, right? 2D data point you can represent as a point in 2D. 1D data point you can represent as a point in 1D, right? Okay. So let's say you are solving this regression problem. So again, in regression, what exactly we do? We predict real valued output for any given input, right? We will predict real valued output for any given input. So here on x-axis we are having sleeping hours, and y-axis we are having grumpiness. So given the sleeping hour, we are predicting grumpiness, right? So it's a regression problem because we are predicting grumpiness, and grumpiness is a real valued output, right? Okay. So here, as you can see, we are plotting input versus output, right? Input here is sleep hours and output here is grumpiness, right? So we are using this 2D plot to show this output input relationship, right? Now suppose if you are having two inputs and one output, then we will plot that input output relationship in 3D, right? So let's say on x-axis you are having first input, y-axis you are having another input, and z-axis you are having the output, right? So then we need 3D plots to show that input output relationship. So from geometric perspectives, regression problem is nothing but to find out the relationship between input and outputs. And here this output is a real valued output, right? So whenever you are doing regression, you are establishing a relationship between input and output using some model, right? And this is nothing but a curve fitting problem or line fitting problem from geometric perspectives, right? So as you can see here, if you solve this regression problem, then what exactly we are doing? We are fitting a line to solve this particular problem. So regression means line fitting problem or curve fitting problem, right? So for example, let's say if you want to solve this particular problem, then it's a curve fitting problem. We are fitting a curve over the training data, right? Okay. So this type of problem is called the regression problem, right? In regression, we model input output relationship, right? Now in classification, we are learning a separators, linear or non-linear separators to separate out data into categories, into classes. So in classification, the goal is to predict which of the two or more classes an input belongs to, because an input may belongs to, let's say, uh, any class. So suppose let's say you are having 10 categories. So that input can belongs to category 0, can belong to category 1. So for example, handwritten digit problem. In case of handwritten digit classification problem, we are having digit 0 to digit 9. So total there are 10 categories, right? And any image can belongs to either handwritten digit 0 category, handwritten digit 1 category, right? So there can be 10 possibilities. So again, this is a classification problem, right? So in classification problem, let's say suppose you are you can solve the binary classification problem, right? And using this linear separator, you can separate out data points into classes, right? In multi-class classification problem, you can find several linear separators. So for example, using these separators, you can separate out these three categories, right? Here again, we are solving a classification problem, but here we are learning a non-linear separator, right? So in these two cases, we are learning a linear separator. Here we are learning a non-linear separator. Non-linear separator to solve the binary classification problem, where we only have the two classes. And this case, we are having a multiple classes where color represent the class, right? So since we are having several colors, so yes. Any doubt here? Okay. Yes. So here we are solving a multi-class classification problem, but here the separator is non-linear, right? As you can see in this figure, we are using non-linear separators to solve this problem. So classification is nothing but learning a linear or non-linear separators, right? Regression is nothing but a line or curve fitting problem, right? From geometric perspectives.
So these both of them are all can only be solved by supervised learning.
Yes.
The regression, so they
regression
can't
and
be done by.
classification. Yes.
They can't be done by unsupervised, right?
No. What sometimes we use unsupervised as a pre-processing techniques to do the supervised task, right? So, for example, let's say you are solving a highly complicated problem. So, what you can do? you can use a divide and conquer type of approach. So what you can do, you can divide a big problem into smaller sub problems, and then you can solve the smaller problem, right? Because smaller, whenever you are dividing a big problem into smaller problems, you are decreasing the complexity of the task, right? Now, how can you divide a big problem into smaller problems? Using clustering, using grouping. So in broader sense, you can use unsupervised learning technique to divide the big problem into smaller problem, and then for each smaller problem you can use the supervised learning technique. So it's not like that every time we will use the only supervised or unsupervised. Even sometimes we also mix supervised and unsupervised, right?
Okay,
But yes,
thanks.
for regression and classification, we need supervision, right? Yes. And this clustering or this grouping problem is again a unsupervised learning problem, because if you want to group your data into multiple groups or multiple clusters, then supervision is not needed. And using unsupervised learning techniques, we can do this type of clustering, right? So from geometric perspectives, clustering is a unsupervised learning problem where we are grouping data points based on their similarities. So as you can see here, all these points that belongs to cluster 1 share similar properties. All these points that belongs to cluster 2 share some similar properties. So here in clustering, depending on the similarity, we will make these groups, right? Again, dimensionality reduction again a unsupervised learning problem. And again, here we do not need the labels, and we can compress our data using dimensionality reduction. So for example, let's say initially we are having a 3-dimensional data, and we are compressing the 3D data to 2D. So since now we have compressed our data from 3D to 2D, so it will take less storage. So we can use dimensionality reduction if you want to compress your data set. And the good thing is dimensionality reduction we can solve using unsupervised learning techniques. We do not need supervision to solve this task, right? Okay. Okay, so I think now this part is clear, right? Supervised, unsupervised, reinforcement, classification, regression. So now can you answer this question? Here we are predicting house price. So to predict house price, should we choose supervised learning workflow or unsupervised learning workflow or reinforcement learning workflow?
Unsupervised.
Okay, so here what type of task we are solving? If we are predicting a house price prediction, are we doing classification or regression?
Regression.
Regression. So if you want to solve the regression problem cannot be solved using unsupervised. So
Okay.
you have to use the supervised learning technique.
Supervised.
Right?
Okay.
Yeah.
Okay.
So that's why if you want to solve this problem, house price prediction, then you will use supervised learning techniques. And the task here is the regression task, because we are predicting real valued output, and we will use batch learning technique here because the complete data set is available with us, right? Okay.
I have a question on the previous point regarding dimensional reduction. So in the workflow, at what stage do we employ a dimensionality reduction?
Yes. Actually, dimensionality reduction I will cover in a detail, right? So, and in fact, I think 2-3 session I will discuss this topic, dimensionality reduction. So, dimensionality reduction mainly we will use when we want to compress the size of data, or let's say when we want to reduce the number of columns, right? So suppose you are solving some task, and to solve the task you are having a tabular data, right? Where the row means you are having data points. So first row means first data point, second row means second data points, and so on. First column means first variable, second column means second variable. So suppose for any given data set you are having 10,000 variables, 10,000 features, right? Now, if you train a machine learning models using 10,000 features, the model that you will learn at the test time will be very slow, right? Because you are processing huge number of features. So then, what you can do, you can use dimensionality reduction techniques to reduce the data dimensionality from 1,000 to 10, or let's say 1,000 to 10,000 to 100. And now you can use only the 100 features, 100 parameters to learn a machine learning model, and that model will be much faster as compared to the previous model, right? So sometimes we require we need dimensionality reduction as a pre-processing to solve the supervised learning problem also, right?
Okay, so before, basically it is done early enough.
Yes,
During
yes,
the
as
early
a
stage.
pre-processing. Sometimes we use as a pre-processing, and sometimes we use this technique to compress the data set size, right?
Okay.
Okay, so next session I will continue from this slide, and I will discuss some performance measures that we can use to judge the performance of our model, right? How our model is performing. For that we need some performance measure. Then only we can measure the performance of our model, right? Okay. Okay. So thank you very much for joining today's session, and next session I will continue from this slide, right?
Can you please share this slide as well? This slide deck.
I think this slide is already available with you, right?
Okay.
So next session is tomorrow morning, right?
Yes, tomorrow morning. And if you want, I can even share this slide also. Just give me.
Yeah, and maybe please share all the links as well to access that material.
Yes, so I have shared the PPT and the link. Okay, so we will meet tomorrow.
Okay, thanks.
Thank you. Thank you.